Now, what does the factor theorem says? It says that you have been given one polynomial. Let's say this is one polynomial ax square plus bx plus c, and this is another polynomial. Let's say x minus a. R of x, this is some one more polynomial x of b, x minus b. So now when we say that q of x is a factor of p of x, when we say that q of x is a factor of p of x, factor means exactly divisible, right? So when we say q of x is a factor of p of x, that means p of x divided by q of x should give us the 0, the remainder should be 0. So ultimately what does it mean? It means that when you substitute x equal to a, the p of a, when you solve p of a, when you solve, you should get the 0. So factor theorem help us to confirm that the given polynomial is a factor of some another polynomial. So in order to confirm that this is a factor of this, right, we'll make use of the remainder theorem. So as per the remainder theorem, if you put x equal to a, and if this is the exactly the factor of this, on putting x equal to a, the p of a should give you 0. Let's see some questions based on this. So this question says that x plus 4 is a factor of this, right? So one thing is we have to prove that x plus 4 is a factor of this given polynomial, and hence ultimately we are required to factorize. So going by the factor theorem and indirectly the remainder theorem, x plus 4 equal to 0, x equal to minus 4. Since x plus 4, it is already given that x plus 4 is a factor of this polynomial. So let's say the polynomial, will label it as p of x, and then substituting p equal to minus 4, the answer should come 0 as per this, right? When we substitute the polynomial, the first polynomial should give you 0. So p of minus 4 should give us 0. Let us substitute and see. P of minus 4 is minus 4 cube plus 9 minus 4 square minus 4 minus 12 minus 128, 16, 16 nines are 144. So this will be plus 144 minus 4 minus 12. So 16 added up, 4 and 12 is 16 added up here, minus 144 plus 144, ultimately it gives 0. So clearly proven x plus 4 is a factor. So that means when x plus 4 is divided by this p of x, we should get 0. So that is what the factor theorem says. Then after that, using the remainder theorem, substituting x equal to minus 4, we should get 0, and ultimately we get a 0. So we can conclude that hence proved. Hence proved. Now further they have asked us to factorize it, right? So one of the factor we have got, that x plus 4 is one of the factor. Then what will be the other factor? So now we are required to use the long division method. So x plus 4 divided by 2x cube plus 9x square plus x minus 12. So just see the first term, right? What should be multiplied by this x? What should be multiplied by this x so as to get 2x cube, right? So if we multiply 2 and x square, So 2 and x square, if we multiply with the x, we get the 2x cube. Just pay attention onto the first term, that what should be multiplied with this first term so as to get the first term over here. So if you multiply 2x square with this first term, you get exactly 2x cube. So it will be 2x cube over here, and 4 multiplied by 2x square is 8x square. Subtraction, just as the normal division, this gives us 0, and this will give you just x square plus x square. Carrying down the remaining terms, plus x minus 12. Now once again the same thing, the first term should be multiplied with by what, so as to give the first term as x square. So simple, we should multiply it with the x. So x multiplied by x gives us the x square, then plus 4x, subtraction, this gives 0, and this will give you minus 3x minus 12. Now what should be multiplied with the x so as to get minus 3x? So minus 3 should be multiplied with the x so as to get the minus 3x. So minus 3x and minus 12, minus 3 into 4 will be minus 12. Ultimately, again doing the subtraction, we get a 0. So we can write it down as the factorization. We can write it down as, therefore, the p of x, which is equal to 2x cube plus 9x square plus x minus 12 can be written as x plus 4 into 2x square plus x minus 3. Now 2x square plus x minus 3 should be further factorized. You should know how to do the factorization. 2 3 is 6, factors of 6 which gives plus 1. So it will be 3 into 2 plus 3x minus 2x. So plus 3 and minus 2 will give you plus 1. X common, 2x plus 3 minus 1 common, 2x plus 3. So x plus 4 is the one factor, x minus 1 is the another factor, 2x plus 3 is the another factor. So this is finally we have factorized. Let us go through the question once again. The question says that show that x plus 4 is a factor of the given polynomial. So to prove that x plus 4 is a factor of this, substituting x equal to minus 4 in the polynomial should give us 0. So we substituted x equal to minus 4, we solved it, and ultimately we got 0. Hence we proved that yes, x plus 4 is one of the factor. The power is 3, so total there are 3 factors. X plus 4 is one of the factor. Hence factorize. One of the factor we got. Since we got 0, we can clearly say that x plus 4 is one of the factor. What about remaining 2 factors? So remaining 2 factors we get by a long division method. X plus 4, 2x cube, 9x square plus x minus 12 divided by x plus 4. First term you are required to pay the attention that what should be multiplied with this first term x, with this first term x, so as to get 2x cube. So if you multiply 2x square into x, you get 2x cube exactly. So just pay attention onto the first term, multiply. The second term also has to be multiplied. 4 into 2 gives you 8x square. Do the regular subtraction, carry down the values, right? Once again, what should be multiplied with the x, right, to get the x square? Now here the first term is x square. So what should be multiplied with the x to get the x square? So it is x. So x into x, x square, x into 4 into x is plus 4x. Subtraction, we get minus 3x minus 12. Now once again the same question, what should be multiplied with the x so as to get minus 3x? So obviously it's minus 3. So minus 3 into x, minus 3x, minus 3 into 4, minus 12. So we get 0, right? So x plus 4, 2x square plus x minus 3 is the another term. This term we need to factorize using the method, and then ultimately we get the three factors of the given polynomial.